Hello, everyone, and welcome back to my channel. Today, we are tackling a topic that is absolutely critical in the cloud era, which is AWS security. It feels like every other day we hear about another data breach, another company compromised, and in a world increasingly powered by cloud platforms like AWS, protecting your digital assets isn't just important, it's non negotiable. The problem is clear. Data breaches are becoming more frequent, more sophisticated, and more damaging. And if your business relies on AWS, then AWS security is crucial to protecting your entire operation. But how do you go beyond just understanding the concepts and actually implement robust security? That's exactly what this video is about. We are going to deep dive hands on into practical security practices to prevent attacks, safeguard your data, and give you peace of mind. I've got a jam packed session ahead. We will start by understanding the AWS security landscape, then move into essential AWS security services. After that, we will get our hands dirty with some live demonstrations of implementing best practices, followed by a look at threat detection and response. Finally, we will wrap up with key takeaways and next steps. Once again, before I start off with the session, please don't forget to hit that subscribe button. So let's kick things off by understanding the fundamental terrain. First up, demystifying AWS security. At its core, AWS security isn't just about firewalls and encryption. It's a holistic approach built on principles like least privilege, defense in depth, and automation. Think of it like building a secure fortress. You need strong walls, multiple checkpoints, and automated guards. We are talking about protecting your data, your applications, and your infrastructure from unauthorized access, malicious attacks, and accidental misconfigurations. It's about ensuring confidentiality, integrity, and availability. Now, let's talk about shared responsibility model. So, this is absolutely crucial. Many people often get this wrong. AWS secures the cloud itself. Things like the physical infrastructure, the global network, and foundational services. This is often called security of the cloud. So, this is responsibility of AWS. But you, the customer, are responsible for security in the cloud. So, your data, your applications, your operating systems, uh, and then network configurations, and then so on, you are responsible for that. So that becomes your security in the cloud. So the infrastructure, the network, and the foundational services is responsibility of AWS, and all the data, the application that you're running, the configurations and everything will be your responsible as a customer. So think of it like a rental car. The rental company maintains the car's engine and brakes. Now that's your security of the car, which is like your security of the cloud. But you, the driver, are responsible for what you put in the car and how you drive it. Now that's a security in the car, which is your security in the cloud. So understanding this distinction is fundamental to building secure applications on AWS. Now, let's look at some common vulnerabilities. So, what are the typical attack vectors? So, the first one we have is misconfigured S3 buckets. So, leaving data publicly accessible by accident is a classic one. You store data in S3 buckets, but then you leave it publicly accessible. Then you have weak IAM policies. So, granting too many permissions can lead to privilege escalation. Then you have unpatched EC2 instances, so running outdated software with known vulnerabilities. So maybe you have an AMI which you have not updated in a long time, so that may contain vulnerabilities. Then lack of logging and monitoring, not knowing when something suspicious is happening. So you're not monitoring for any attacks or for any suspicious activities. You're not doing any of those things. And then insecure network configuration. So you have opened up certain ports which are not required. You have allowed the traffic from everywhere, weak security groups. All these things leads to insecure network configurations. Now we will address all of these and more as we go through our hands-on examples. Now, now that we understand the landscape, let's explore some of the AWS most powerful security services. So the first one we have is IAM, or Identity and Access Management. Now this is the bedrock of AWS security. We can use this to manage the access to your AWS, and then under what conditions. So as to who can access, what they can access, all those things can be controlled. So let's demonstrate setting up user roles and then policies. So here I'm in the AWS console. So let's go to the IAM service, and I'm going to create a new user, and let's say for read only analyst. So let's go to users and we'll create a new user, and let's call this as read only analyst, and next. Now, instead of giving them root access, which is full access, which is a huge no-no, we will attach a very specific policy, right? So let's say we will attach a policy directly, and let's search for S3 read-only access. So this is what I'm going with, Amazon S3 read-only access. Now let's go ahead, next, create user. Now this user can read from any S3 bucket. So you can see the resource, it says asterisk, it's a wildcard. But what if we want to be more granular? So let's go ahead and create a new custom policy. So we'll go to the policies and we'll create a new policy, and let's go with the editor so that we can give the JSON over here. So this is the JSON policy that I'm using. Now notice how we can define not just what action, so we are allowing get object and list object, but also on what specific resources we are allowing the action. So I'm telling I want to allow access only on this particular bucket. Now this becomes more granular. So this is the principle of least privilege in action, giving users only the permissions they absolutely need to do their job and nothing more. We can also create roles for EC2 instances or Lambda functions, so they don't need hard coded credentials. So, we can go to next, we can give it a name. So, let's say um, bucket read only access, and then we can create this policy. And then we can attach this policy to our user. So what I can do is I can remove this particular permission, and I can attach the new policy that we have created. So let me search for the one that we created. So here it is, and we can attach this. So now this becomes the least privilege for us. So we are only giving the access that is needed and nothing else. Next, we have key management service, or KMS. So encryption is your best friend when it comes to data protection, and KMS makes it easier for us to manage the encryption keys. So whenever we talk about encrypting your data, we make use of your KMS service to generate the encryption keys and then encrypt our data. So let's create a customer managed key in KMS. So let me search for KMS. So there's my service. So we'll go to the service. So this is the KMS console. So we'll go to create a key, and we'll go with symmetric, and we'll use the same key to encrypt and decrypt. Next, alias name, if you want, you can give. So let's say demo. Next, you can set the administrators as to who gets the administrator access. Next, who can use these keys. Next, you get to review, and then next, and then finish. So this will create the encryption key for us. Now, imagine we have a S3 bucket. So let's go here, and okay, so this is the bucket. Sorry. So properties, edit, Okay, so demo, so that's the one. And save change. Sorry about that. I got a bit confused. And now we have enabled the encryption. So this means AWS encrypts the data before it's stored and decrypts it when accessed. All using our managed key. So KMS also allows for automatic rotation of your key. So you can see here key material and rotation. So you can specify if you want to automatically rotate this. Now this is very critical security best practice. So this can help you to limit the lifespan of a single encryption key. Now, let's talk about security groups and NACLs. Now, these are your virtual firewalls in AWS, and we can use them as your network security controls for your instances. So, let's say here I have, let's go to EC2, and let's say I want to launch a new EC2 instance. So, let's go ahead, and here you have the option of configuring your firewall, which is your security group. So a security group, it acts at the instance level and it is stateful. So here you have two types of rules. You'll have the inbound rule and the outbound rule. So if you allow inbound rule, the outbound traffic is automatically allowed. So let's say you can either create a rule, meaning you can create a security group first, and then you can select it here as an existing group, or you can create it here as well. So you can give it a name, a description, and then the rule. So here I have SSH, which is your port 22 by default, and then from where you want to allow. Now this is very important. So let's say custom, and you can give a range. So something like, let's say 203.0.113.0/24, right? Likewise, you can add more rules. So let's say I want to add HTTP, so I can search for HTTP, sorry, and then this one, let's say from anywhere. Likewise, I can allow for HTTPS, and again from anywhere. So 0.0.0 indicates anywhere. So this security group now ensures that the instance that I'm launching, let's say it's a web server instance, now this will allow SSH only from this IP range, right? And then HTTP and HTTPS traffic from the internet, anywhere from the internet. Now, all other inbound traffic is implicitly denied. Only these three traffics will be allowed, all other traffics will be denied. And then you have your NACLs. So let's go to VPC. So NACLs, on the other hand, they operate at the subnet level and they are stateless. This means whenever you're creating your NACL, so let's say demo, and we'll map it to our VPC. So whenever you are adding your rules, you will need to explicitly allow both inbound and outbound traffic. Now this provides an additional layer of defense for you. So let's say we'll add a new rule. So let's add a new rule and let's call this as rule 100. And then what traffic? So let's say all traffic, and then I want to allow from anywhere. Likewise, so let's say, let me save these changes. Likewise, you'll need to explicitly define your outbound traffic as well. So unlike your security groups, where the outbound traffic is automatically managed, NACLs you will need to explicitly do so. So NACLs have explicit deny rules, and they are evaluated by a rule number. A lowest um, to basically the lowest number gets the first priority. This means you have a bit more control, but also more complexity. Think of security groups as allowing specific people into a building, while NACLs are like airport security for entire sections of the airport. So used together, they can create a very powerful network defense. Now, let's put all this together with some practical hands-on best practices. So first, we are going to build a secure EC2 instance. Now, this is often the entry point for attackers. Now, when launching an EC2 instance, beyond just the security group, you have a few more things that you need to consider. The first one you have is using a hardened AMI. So start with an Amazon machine image that's already patched and secured. For production, look for AMIs like Amazon Linux 2023 or Ubuntu LTS and ensure they are regularly updated. So whenever you are launching your instances, make sure you're selecting the updated AMI. So in this case, you can say I'm going with 2023. Likewise, you may have other AMIs that you can choose from, but try to use AMIs that are up to date and also which receives regular updates. So let's say I'll go with Amazon Linux just for the sake of example. Then let me set this. We'll select an existing security group. Then user data scripts for initial hardening. So we can use user data scripts to perform initial security configurations immediately on launch. So here you can go to advanced settings and here you should be able to see the user data section. So let me give, so this is a script that I'm using. So what are we doing here is we are updating the machine first, then I'm installing an Apache server, I'm starting it and I'm enabling it. I'm adding this content to my index.html file. Then I am disabling root login over SSH, so you cannot log in as a root. Then I'm creating a non-root user. I am setting the password, and then I'm basically granting it sudo access. Then here you have the option of removing the default SSH key for authentication for security if you're not managing it centrally. So here you can see I am removing these authorized keys from this location, from this location. It depends on what you're using. For Amazon Linux, this is what you'll be using. For Ubuntu, it will be /home/Ubuntu and then the path. So this script automatically updates the system, installs a basic web server, disables direct root login over SSH, and creates a new administrative user. Now these are crucial initial steps for hardening. Then instance monitoring. So beyond basic CloudWatch metrics, consider more in-depth monitoring. We will touch on CloudWatch and CloudTrail later. But for EC2, you can also install the CloudWatch agent to collect more detailed metrics from within the OS like memory and disk utilization. Then you have SSH key management. So always use strong SSH key pairs. Never use password based authentication for SSH. Store your private keys securely offline. If possible, consider using AWS Systems Manager Session Manager for passwordless, keyless access, which removes the need to open SSH ports entirely. Next, we have S3 buckets. Now, this is prime target for data breaches. So let's secure your S3 bucket. So for this, you can either create a new bucket. So for this, you can either create a new bucket or you can choose an existing one if you already have a bucket. That's totally up to you. So the first thing you have is block public access by default. AWS now defaults to blocking public access, but always double check. So here, if you go to permissions, so you have this block public access. So always make sure your public access is blocked. Then data encryption at rest. So enable default encryption using S3 managed keys or your KMS keys, the one that I showed you earlier. Then data encryption in transit. So enforce encryption in transit using bucket policies. This means users must connect over HTTPS. So how can you do that? So here is the example bucket policy. So we are denying unencrypted access to get the object from the bucket. So I'll need to change the bucket name. So basically this is the ARN. So I can change that over here. And then secure transport is set to false. So if the secure transport is set to false, then deny the access to the bucket. So this policy explicitly denies any get object request to our bucket if it's not made over a secure transport, which is your HTTPS. Now this is very crucial. Then configure bucket policies for specific access. So use bucket policies for fine-grained access control that goes beyond IAM users, such as allowing access only from specific VPC endpoints. And then enable versioning. So protect against accidental deletion or overwrites of your data. So in your S3 bucket, if you go back to your S3 bucket under properties, you have the bucket version. So you can enable this so that you can avoid any accidental deletion of your data or overwrites of your data. Finally, for this section, setting up Cloud Trial and CloudWatch. Now these are your eyes and ears in AWS. So Cloud Trial helps you to record all the API calls in your AWS and also all the events in AWS. So no, any activity that you do, log into the console or creating an instance, creating a user, creating a bucket, any activity you do, all that event will be captured in Cloud Trial. So this is your audit log. So how do you work with this? So you can go to the Cloud Trial service and you have the option of um, creating a trial. So let me open this up. Okay, so you can go to trials and then create trial. You can give it a name and then where do you want to store these details? So you want to store it in S3 bucket. So you can either create a new bucket or you can choose an existing one. That's totally your choice. I'll just select this one. Then you want to encrypt it. Do you want to create a new one or you want to use an existing one? Do you want to validate the log file validation? Do you want to send out a notification? Do you also want to send this to CloudWatch? All those things can be configured. Now the recommendation would be to ensure that this logging is happening in a separate S3 bucket which is in a separate account. That way, even if your main account is compromised, your audit logs will remain safe. Then you have your CloudWatch, which can be used to collect monitoring data and operational data in the form of logs, metrics, and events. So basically, anything that you want to monitor, we can do that by making use of your CloudWatch service. Now that's your monitoring service in AWS. So anything you want to monitor, we make use of your monitoring for that. So let's create an alarm to detect if someone tries to stop CloudTrail logging. Now, this is a common tactic for attackers to hide their tracks. So you can go to log groups and then you can choose the log group. So at this point I have only two log groups. So just for the sake of example, we'll select that and you can create a log group. You can give it a name and fill in few more details. So let's call this as demo and then create. Now here you can search your log group. So this does not have any event, but as you start using more and more of your AWS account, you will see that um, you will have all the logs available here. But the point is you can use this to monitor certain event in your AWS, and then you can also set up alerts. So whenever that event happens, a notification will be triggered. So you can use SNS to set up that notification, which will send out an email notification. So this proactive monitoring is very key in AWS. You have to be as proactive as possible and not wait for the threats or the events to happen. Now, next, let's talk about threat detection and response in AWS. So, even with the best preventive measures, you need to be prepared for the worst as well. So, we'll talk about your threat detection and responses. So, for that, we will talk about leveraging Cloud Trial for security auditing. So, we touched on your Cloud Trial earlier. Now, let's leverage it for security auditing. So here in this Cloud Trial console, you can go to this event history. Now this event history will maintain all the events that has happened for the last 90 days. And here you can filter events. So let's say you suspect unauthorized access to an S3 bucket. You can filter it by going to the resource type and then looking for bucket. So you can search, so AWS S3 bucket, and then you can look for the event name. So you can see there's a delete bucket over here, or put bucket or whatever it is. So you can click on this and you can see the details who did this. So this was done via a role. So this is the role, and this is the account ID from this instance. So this instance this role was attached to this instance, and from there this bucket was deleted. So you can see which bucket, and all those details will be available for you. So this allows you to trace exactly who did what, when, and from where. For instance, if you see a delete object event from an unexpected IP address or an IAM user that should not have delete permissions, you've got a clear lead for investigation. It's invaluable for incident response and forensic analysis. You can also send CloudTrail logs to CloudWatch logs for more advanced queries and real-time analysis using CloudWatch log insights. Next, let's talk about exploring the AWS Security Hub. Now, this service gives you a comprehensive view of your high priority security alerts and compliance status across your AWS accounts. So, we have this another service called Security Hub that you can use. Now, Security Hub aggregates security findings from various AWS services like Guard Duty for threat detection, Inspector for vulnerability management, and Macy for sensitive data recovery, and even partner solutions. Now, here, I'm using it for the first time, so there's few configurations that you will need to do, but you can enable this, and you can see here you have AWS Inspector, Guard Duty, Messy, all these things will be available for you. And if you go to the hub, you should be able to see. So, what are the exposures you have, what are the threats you have, what are the vulnerabilities you have. All those details will be available. When I just enabled it, so this will take some time. If there are details, it will take some time to reflect. But ideally, you can get this information. So it automatically runs automated security checks against industry best practices and compliance in standards like the CIS AWS Foundation's benchmark. Now, this will help you to centralize your security findings, provide a prioritized list of issues, and make managing vulnerabilities much more efficient. It's like having a security operations center aggregated in one dashboard. Finally, while AWS provides robust native services, sometimes you need to integrate them with third party security tools. So many organizations have existing security information and event management systems or security orchestration, automation, and response platforms. So AWS plays nicely with this. For instance, you can stream CloudTrail logs to Splunk for centralized log analysis across your on-premises and cloud environments, or use Security Hub findings to trigger automated responses to a SOAR platform to block malicious IPs or isolate compromised instances. These integrations allow for a unified security posture across your hybrid or multi-cloud environment. Wow, we have covered a lot of ground today. So let's quickly recap the key principles and best practices we have discussed. So understand the shared responsibility model. Know your role in securing the cloud. Implement least privilege with IAM. So give only the necessary permissions. Encrypt everything. So data at rest and in transit using KMS and service level encryption. Layered network security. So leverage security groups and NACLs. Harden your instances and services. Don't leave default configurations exposed. Log and monitor everything. CloudTrail and CloudWatch are your best friends for visibility. And then finally, proactive threat detection. So use services like Security Hub to get proactive detection of your threats. So security is not a one-time setup, it's a continuous journey. So here are some practical tips for ongoing improvement. Regularly review your IAM policies. Are permissions still appropriate for a user or roles? Conduct security audits. So use tools like AWS config rules or third-party solutions for automated checks. Stay updated. So keep your AMIs and applications patched. Automate patching where possible. Automate security. So use infrastructure as code tools like CloudFormation or Terraform to bake security into your deployments from the start. Practice incident response. Have a well-defined plan for when something does go wrong, and conduct regular tabletop exercises. And then finally, educate your team. So security is everyone's responsibility. Have regular training, which is very crucial. So mastering AWS security is an ongoing commitment. But with these hands-on best practices, you are well on your way to build a more resilient and secure cloud environment. If you found this video helpful, please give it a thumbs up. Subscribe for more practical cloud guides and let me know in the comments section what other AWS topics you would like me to cover. Thank you for watching and I will see you in the next video.